not back yet, make sure that you come back because we have Moody Hadi and Sarash Araya who are up next, and they're with S&P Global, and they're going to be talking about leveraging data science and credit analytics, which is the perfect topic for this event. So we're really excited and welcome, guys.
Yeah, thank you very much for coming. Yeah, we're going to be talking about leveraging data science and analytics. Sorry, I was. um, yeah. So Saransh and I were part of the new product development team in credit analytics at S&P Global Market Intelligence. We use a lot of data sciences in our products. Today's basically chat is mostly about looking at basically, machine learning and data sciences are very contemporary topics. At S&P, we use them quite a bit for a lot of our risk management applications. We're going to present a framework for assessing sort of machine learning and data science to the business people in a way that can explain some of these sort of difficult or technical topics to sort of the business side. We'll also go through a couple of examples that show how we actually use some of these techniques in our risk management, credit risk management applications, and we'll go over some of the technical architectures as well as the future extensions and open it up to Q&A. So a little bit about S&P because it is a big company. So S&P Global really is kind of there are several business lines, but the major business lines are S&P ratings, where we're doing uppercase ratings on countries and companies globally. S&P indices, which are the S&P 500, the Dow Jones indices. So that's quite a bit side of the business. S&P Global Commodity Insights, which is an energy-focused research side of the business, and S&P Global Market Intelligence, which is the division I belong into, which is a data and analytics provider, typically focused on risk management applications. So within market intelligence, we have several business lines, and the business line we belong to is on the credit risk side of it. So we focus on credit risk, market risk, operational risk. Today we'll be talking about credit analytics, which is a lot of it is focused on credit and liquidity risk management. So yeah, I mean, the general overview is, we'll go over the general data science applications, and Saransh will kind of go through this. Then we'll see how we applied those approaches into the credit risk management applications, and we'll conclude with Q&A and further extensions. Saransh, you want to? Sure. You just it takes a little bit. Yeah. Just click.
Okay, thank you, Moody. So to kick it off with, like Moody mentioned, we'll start with a general pipeline of how we go about it and then get into the specifics. So to begin with, the first step always is to cater to the business problem. And the first part to look at is what the problem is. The client doesn't really care what technology you use behind it. For him, data science, machine learning is just a means. For him, the ultimate goal is a satisfactory level of a solution which can help to solve the business problem. So that's where we first look at, and then accordingly we decide what means works the best. It might not always be machine learning, but it kind of is also, machine learning goes hand in hand with other. So yeah, so the first step is basically looking at the data preparation, right? These are the four kind of steps in which you can break down once you have decided that you are using machine learning, let's say. These are the four steps in which you can break it down. The first one is preparing the data. I know we hear it a lot, and I'm sure you've all heard it all the time, that data is the key for any machine learning model. And we were also discussing before this about synthetic data and understanding the importance of data. So the first part is sourcing your data, pre-processing it, cleaning that data, getting it ready for the model to understand what the data is for the model to train on. And then it comes down to the model definition. So you have the data, now you have to define what your target variable is. What can I derive from this data that I have sourced? And after that, there are certain different models that you can go with, which we'll come to later, that how you decide what model works better for your problem. But at the same time, there are different models that you pick that, for this problem, these are the suitable ones. And then you move on to the training and testing part. Training is basically, understanding, trying different combination, which for the technical terms like hyperparameter tuning, and all those steps come into the place. How much do I want to train, and how how much training is required, how much data should be good. So the question that also came up before was, how do I decide how much data is enough data? So I'll have some further slides which can also help in realizing that. And then finally, the model use, which is to evaluate and deploy it in production and produce prediction on our live data that we'll eventually have. Yeah, so this is what I was talking about, the variance bias trade-off. So you have to understand what the business problem best is to, what we are trying to achieve in the business problem. And then we also have to see how to find that sweet spot between the variance of our model versus the bias. So if we see here a random forest, which is used a lot in our day-to-day work, is kind of overfitting on the data, whereas nonlinear regression, whereas a quadratic regression is kind of just underfitting. So bias variance also, we use overfitting and underfitting as terms, which are kind of the same. So by looking at this graph, I kind of understand also that how I should proceed with my data. Do I need more data or not? And along with just picking the model. So that's kind of some of the things that we look at, whether random forest is good or the other model. And in the real world, it's kind of difficult, like the previous graph made it kind of easy to look at. But when we go to the real world applications, it's kind of a little trickier to find that sweet spot. And you basically have to go through different methods to understand where to stop. Where do you stop your training? Whether you add more data, whether this data is enough, and so on and so forth. So these are some of the general things that a lot of you would have already applied, a lot of you would have heard of in a typical machine learning problem assessment. And so once we have all those things, right, it's also important to understand that what model, like accuracy is one thing, the result is one thing, but sometimes to get to the business, to put the idea across to the business, we need more understanding of how that thing is happening. So we have to understand the trade-off between complexity and supervision as well. How much transparency is there in a model? How easy it is to understand why the model made that decision. So these are different models, like traditional logistic regression model, and then there's random forest, gradient boosting. And along with that, you also look at the considerations that why, yes, this is high in supervision, this one is high in complexity. I have to keep the business problem into mind, and then I have to pick, using those few considerations which have been highlighted on the slide, that which one is best suited for my problem. And in credit analytics, right, we often see that there has to be a transparency, the explainability behind every decision that we take. So we have to keep all these things in mind when we are picking our solutions, when we are picking the model that we go ahead with. Moving on. Yeah, so till now I was explaining kind of the pipeline of how we start from collecting data, sourcing data, all the way till deciding between the different models that I have, which one to pick. But this is a quick overview of one of the processes that is used a lot in credit, which is sentiment analysis. So again, in sentiment analysis, it's technical, it's textual data, and you keep hearing with textual data, NLP, LLMs, all these things these days. But at the same time, it is still the problem of transparency, the problem of explainability is here as well. We need to understand, like if you see this chart here, the left side of the chart is more deterministic. I'm going more with the bag of word approach. Whereas the right part is talking more of the deep learning applications that we are seeing, neural network applications which further go into LLMs and all. But that's the thing that we need to understand. LLMs are there, neural networks are there, which are more complex. But at the same time, there can be a business problem, which is still an NLP business problem, which can still have your sentiment analysis. But they still take up the deterministic route, because we are better able to explain why we did it. We are better able to judge the weights behind everything. which kind of gets a little complicated in the neural networks and because that utilizes back propagation and so on. Yeah.
Like in our transcript product that basically does polarities on earnings calls, right? We use a regularized bag of words specifically to have very high amount of transparency and attribution to how we calculate the sentiment. Versus, for example, a neural network approach, where you might have to apply some model agnostic explanations or shape values, which will be much more difficult to explain to the audience that's actually waiting to understand where that polarity came from, right? So in other cases, we've got like products that look at, for example, Chinese public disclosures, right? Those ones, the language is difficult. The approach requires maybe less transparency in a way. That, for example, is a deep learning model. So you kind of want to balance this out, because that's depending on what sort of area you're focused on. So, yep, go ahead.
So just what Moody covered, right? Like plain bag of words, high supervision, low complexity. Whereas if you have a use case where you require a more complex model, you have to kind of give up a bit on the supervision. So it's again finding your own sweet spot based on the business problem that you're dealing with, based on the client's expectation of a satisfactory solution that you're looking at. So these are again some considerations that you have to look at or we look at when we are developing our solutions. So from getting a bit more in the delivery process side, there are two steps, basically main delivery processes that I can think of in a machine learning application. The first one essentially is the proof of concept, where we are trying something new. We want to see whether it works or not. So it's a relatively easier infrastructure that we set up. Like we source the data, the data scientist or an engineer will develop the model, spin up the infra, and try that model and see whether it's ready for operationalization or not. How the POC, are we able to say that a POC was a success? But at the same time, there's also the operationalization part that has to be kept in mind throughout the process, which is where we, like in the above part, we are showing what a data scientist goes through, performs his exploratory data analysis, works on the model, assesses the weights, and eventually, uploads it into a repository. But at the same time, for a user, it's more of the deriving the ML insights. What is the back end of that? It's a completely different, thing that we have to keep in mind while developing the solution. It's not that it has to happen later on. It has to all go in parallel. So that's the delivery process, even though that's the operationalization bit, but it still has to go in parallel while you are doing the development. And so moving on to more of our credit risk management applications where we are currently working on. So the first one is, like we mentioned initially, these are some of the more important parts that we have to keep in mind. Our models have to be transparent, they have to be explainable. We have to have a good coverage. We are basically giving a score to companies, and we have to make sure that we are covering a good amount of companies for a client to actually derive value from that product. At the same time, what's also important to understand is the timeliness of the data. Like if you're looking at data which is historic data, it might not be an accurate picture of what the current situation of a company is, what the current health of a company is, and at the same time reliability. Like that's the model has to be reliable. What it's bringing can be explained, and all the points that we have already covered.
I'd like to give you an idea of like size or magnitude of coverage. Like typically the rating agencies, right, they're covering sort of tens of thousands of companies. On the model-based piece, which we call credit analytics, we're covering millions of companies. So you're not going to have material non-public information, millions of people assessing every small business that you're assessing. So you're going to have a structural model, and some of the approaches we'll talk about to actually kind of create transparency around what that business is doing to kind of create exposure limits and strike basically a fair sort of lending rate. So, but that's the magnitude of a problem on the credit analytics side that we're trying to solve. Is typically in the millions of companies globally. Yep.
Yeah, and if you're looking at millions of companies, it's not always feasible to get the financials of the company. So along with that, what we are also doing is currently looking at the digital footprint of a company to come up with indicators which can help, the qualitative indicators which can then be fed into our systematic model and help in generating the health of a company. So this is one of the things that we are currently working on, which is how to go from that digital footprint, the website, which is the primary source of the company, and other presence of the company online, and take those indicators, take those inputs, and be able to derive the health of a company. So this slide kind of mentions the veracity level of different sources. Like the first level is usually the website of a company. That's the most accurate data that you'll get, right? So that is the first thing that we want to tap into as a source of whatever decision we make. The data that we are sourcing, we want to get that data directly from what the company is saying. Then on top of that, there are other sources of information that we are also looking at. These can be journalistic articles, legal proceedings around that company, right? It's a little, I would say, it's a little. Some of the details come out after the case has happened, but it's really high on veracity. And then the further you go away, the more you go into social media, the veracity reduces. And this is kind of a pipeline of sorts that we are currently working on. We start with the crawlers, which is the public and private company data on the website. We use a technology like web crawlers, web watchers. We get the data, and then, like I said, the second part becomes pre-processing of the data, cleaning the data, how it can be fed into the model, and then so that part comes in because on a website there's a lot of noise. We need to get rid of the noise from our data and then only run our miners on top of data which is relevant. These miners include the information we are currently considering include people, industry, and so on. And after that, once we have this information, once we run, let's say, our NLP models to get people data and so on, we have to put all of this in a structured database from which information can directly be fed into our model, the analytical engine which I'm talking about here, which is the risk gauge as mentioned on this slide. In addition to that, we understand, that through self-source, we can't cover the entire universe. There would still be some pieces which are missing. So to fill those pieces, we are also looking at third-party sourced information. And here, when we have to bring in a third-party information, we also have to do some analysis to make sure it's relevant for the use case we are looking at. So that's where we also utilize some machine learning approaches, techniques, to even perform the EDA. It's the data analysis. We don't just look at it to train a model, but we often find some techniques within this machine learning world which can help us in performing that data analysis to help us realize whether that new data, whether that third-party information is of relevance for what we are trying to solve or not. So that is another place where we utilize machine learning, but to come up with solution and utilize third-party information.
Yeah, some things kind of happen on the slide, but generally, it's not like we're building a model that's completely, say, neural network based or random forest, and then immediately using that to score distance to default. What we do is we take relatively large data from third parties, figure out what the important features that could be relevant to the structural model, mine it using neural networks or basically random forest, and then create effectively simple factors that go into the structural model. So the end client is really looking at still a structural model, but under the hood, a lot of the data that is non-financial came through basically machine learning, or down the line, hopefully LLMs. So it's not so much that you jump the whole thing into using those techniques directly to score the entity, because they are kind of opaque and it's hard to defend in a lot of cases. Especially in this situation where we're dealing with business-to-business lending, not business-to-consumer, right? So we're only institutional credit focused. Yeah.
Great. So this now we'll basically use a case study of sorts of one of the solution that we provide, which is for spreading financial information. So a lot of companies or banks, they have they perform spreading of financial statements where they get proprietary statements and they have to manually pick data from those statements and add them in their own systems. So this solution was built to cater to that issue, where essentially you feed your own PDF to the to this solution to ProSpread, and it will run on top of that PDF and generate the score, generate your own spreading by itself. It will perform spreading by itself and get all the data, relevant data, into your systems. So if, as we can see here, but the question is, how did we do it? And this was like a step-by-step approach. We first take the document, which goes through the extraction, where we perform OCR. So that kind of makes it agnostic to the type of document that you're looking at. It can be an image document, it can be a machine-readable document. So we convert it into image, we perform OCR on top of it, get structured output with metadata, and then utilizing some NLP techniques, we perform assignment function to identify what data belongs to which data item. And then we also provide the user the option to edit that himself, because a lot of times it might be the user's assignments can be different from the way we assign it. So the user can further go and edit those things and then further utilize a balancing aspect, which is a part of ProSpread, to compare and to aggregate data items and then feed it into the systems as per their own structures. And eventually we finally get the output as can be seen at the bottom, and we can generate score also directly out of it. So if you look at it, we have our own pipeline of Salesforce data. We are aggregating it with third-party data. And at the same time, if we are still missing out on something, we provide ProSpread, where client can look at proprietary data themselves. They still don't have to like perform it manually. They can utilize this solution, run it through the financial statements, and generate the score in an automated manner. This is a little bit more on the architectural side. I know we are running a bit behind time, so I'll quickly just skim through it. It covers the extraction part, the detection part, extraction being the OCR image classification, then the detection part of tables, detecting tables, then the assignment engine, which finally figures out the data items that are being shown, followed by the scoring engine. And in a lot, there's always that aspect of user feedback, where they can go into this and they can improve, they can change some things as per their requirements. So you can try it out if you want. ProSpread, we have further details of ProSpread and credit analytics on these links, which you can refer to and get further details. To conclude, and I'll just come to the future extensions, these are some of the PLMs and LLMs we are looking at, BERT, BART, and language models which we utilize and which we are looking at. And then you can also, in addition to these, you can use LIME algorithm, which helps you in explainability of models and model transparency. And yeah, we are hiring. Go ahead.
I'm very excited. We're hiring. Yeah, so we're always looking for people in combination of machine learning and credit risk management, typically on the institutional side. So we're constantly growing the team. So we're obviously looking at head of market development, senior data scientists, directors in product management. So please, go to the careers page. I just kind of picked a few ones that are sort of top of mind. But yeah, feel free to apply if you're interested. If you go to the next one.
Yeah.
I mean, yeah, so basically, it's okay. So, thank you. You can see, there's a lot going on in market intelligence, especially in credit analytics, trying to use and leverage these ML techniques in different ways to serve our customers. And, we're constantly expanding in this area, right? So, thank you. I'm going to open this to Q&A if anybody wants to ask questions. I'm a bit behind. I'm sorry, Anna.